All right, welcome back, boys and girls, to a special live taped edition of the drive-thru. Let's hear it, everybody. All right, hey, today is not sponsored by the deli. It's sponsored by Sycamore Lady A's soccer and volleyball and boys soccer. Do you guys play today? Okay, you guys just happen to be wearing the same shirt today. You're throwing me off. The sponsorship has been ruined. All right, shout out to the Lady A's soccer and volleyball who play the tournament today. We're really pulling for them. 4-3, ARAT. A right angle theorem. ARAT, okay? ARAT states if two angles are both supplementary and congruent, then those are two right angles, okay? This would be a pretty easy proof. You would say angle 1 plus angle 2 equals 180, right? Angle 1 equals angle 2. Then you'd substitute angle 1 in, and you'd say angle 1 plus angle 1 equals 180. And what's another way to say angle 1 plus angle 1? 2 times angle 1 equals 180. Divide each side by 2. Angle 1 equals 90. Angle 2 equals 90. They're right angles. Do you buy it now? Now you don't have to do that anymore. You can just use the theorem in your proofs. Got it? All right. Second slide. This theorem, this simple little obvious theorem, is actually going to open the door to a lot of new types of proofs. Okay? So that just means you're going to get to further your enjoyment with further challenge. It's going to be a great day for you guys. Okay? All right. Here is a review definition. We knew this, but I don't think we knew it very well, because it's evident to me that we are consistently getting median and altitude kind of confused. So here's another one now. This is called the perpendicular bisector. You have already learned this. If a line or a segment or array is a perpendicular bisector of a segment, then the line forms right angles with that segment and divides the segment into two congruent segments. Okay, that's a lot. So let's think about what it's saying. First of all, only a segment can be bisected. Do you get that? You cannot bisect a ray or a line. Why not? That's right, because their length is infinity. And what's half of infinity? Infinity. It's not nothing. Half of infinity is infinity, which is really confusing, and that's why you can't bisect a line. Does that make sense? If you're interested in infinity, then good for you. There's a course called calculus, and you'll enjoy it. That's basically kind of the foundation of calculus. All right, so look, let's choose a line. And then let me move this thing down, because I think I drew it off just a little bit. All right, good. If I make this mark, and I make that mark, now we've got a perpendicular bisector. Which colored segment is the perpendicular bisector? Or which colored object, I should say? Jack? The red object is the perpendicular bisector. Does that make sense? So the blue object, which is a segment, has been bisected at a perpendicular. Do you get that? Okay, we once learned that, but it's a really important thing to grasp as we move forward. We're going to do one proof with this, and that'll be the whole lecture for today. But this is going to be a rather lengthy proof, and so that we fit it all on one page, I'm going to try something a little new here with you guys. I'm going to, start the proof here, and then finish it on the right, because I think this is going to take about 12 steps, and I can't fit them all on one board. All right, you ready for this? So we are given that AB is congruent to AD, and that BC is congruent to DC. Now we're trying to prove that AC is the perpendicular bisector of BD. So You're familiar with that, right? All right. So let's think about this. How are we going to have to do this? Well, now, our last step is probably going to be the definition of perpendicular bisector, right? Well, we just put the definition of perpendicular bisector up the previous board. What are we going to have to show? Go ahead. We're going to have to show that E is a right angle somewhere. And what else? So then we're going to have to show that BE is congruent to? That's right. So now we've got like a proof that's kind of two proofs in one. So here we go. I'm going to just start by saying that AC is congruent to itself by reflexive. And now you should know what my next step is going to be. What is it? Okay, which triangles? Triangle ABC is congruent to triangle ADC. And Johnny, what's my reason? Very good. Okay? All right. I got an idea how I want to do this now. Okay? I've just proven that the top triangle was congruent to the bottom triangle. So now I'm going to get the triangle AEB is congruent to triangle AED, and then I think I'll be able to do all the little things that I need to do to prove perpendicular bisector. So help me do that. What's my next step? Excellent. Angle BAC is congruent to angle DAC, and the reason is CPCTC. Very good. Now I think there's only one step that would make the most sense. Johnny, you want to keep going? AE is congruent to AE. Once again, that's reflexive. I'll get out of the way for you guys. So let's mark this thing up. We were given that. We CPCTC'd to get this, and we just stated that. So now can you see what we're going to do next? Go ahead, John. Triangle AEB is congruent to triangle AED. Now we got SAS there. Okay? Right? So while I'm here, Johnny, I'm just going to write this down. BE is congruent to DE. What's my reason for that? Okay? Now I'm just going to like bank that in my wonderfully terrible memory to remind myself I'm halfway there. So now what's my goal now? I've just got to prove that they're right angles. Well, I don't think that's going to be all that difficult. Especially if I paid attention earlier in the video. I can say that angle AEB is congruent to angle AED. What allows me to say that? CPCTC. Okay? And as a little aside, this is a cool part of this class. We've now done proofs for long enough that everyone has had a fair chance to practice. So every kid that has been working hard and maybe struggled 3 weeks ago, they have gotten their chance to catch up now. And now these just become like tricky little, like almost like Sudoku problems. You've just got to figure out how to work through them, okay? And so it becomes a different student now becomes successful. It's not just the smartest student anymore. It's a student that's willing to kind of put the most work in, which is a good thing. Okay? That's how life works. All right, so now, what do I have to say next to use our new hot little theorem? Good. AEB, angle AEB is supplementary to angle AED. And what allows me to say that? Assume from diagram. You can see what I mean right there. Like, we haven't used that in a while. And we used to only use it for the congruent supplements theorem. And now, like, people are being able to use more of the things that they've learned, which is a great thing. So now, what can we say next? That's right. Angle AEB and angle AED are right angles. That's right. That's right. A right angle theorem. I don't like that at all, but that's what they call it, so we call it ARAT. Okay? Now what can I say, Clause A? That's right. Look. AC is the perpendicular bisector of BD. And my reason? Definition of perp bisector. And then if I wanted bisector, and then if I wanted to be a boss, I'd be like 7, 10. See those steps. Does that make sense? Can I get a boom loudly? That was weak.